All right, so we are going to be learning about how to calculate different concentrations of things and really just playing around with different units. So depending on different consumer products or just different uses, maybe for like saline solution that might be used in a hospital, there tends to be typical expectations of how certain things are reported as far as concentration amounts. So the first one that we're going to be learning about is how would we express concentration in something that would be mass percent. But when we first just think about concentration, the definition of solution concentration is the amount of solute present in a specific or a specified amount of solution. So this mass percent one, if we were to look at the formula, and remember, you are able to use all reference sheets that you have. I will show you in a little bit where these formulas are on your reference sheet. But mass percent is going to equal the mass of your solute divided by the mass of your solution. And then if we need to turn that into a percent, like what we have done in the past, just multiply by 100%. So we could see this written as a mass percent, so 5% m/m. And if you start doing a little exploring at home with some of your different solutions that you might have in your house, you'll probably start to see some specific information about this, and we'll probably give you a little bit of a task of looking for something like that later on. It could be weight percent as well. So for this specific situation, we aren't going to say that it has to be by mass or by weight. It's the same no matter. So let's run through this example problem. It says how many grams of lithium chloride are in a 100 gram 5% by mass solution. So in this particular case, we have already been given the mass percent of 5%. We're being asked how much solute. And it's going to be really important as you learn about these different things that you're really paying attention to what solute definition means and what solution definition means, and what, this could change whenever we're looking at these different scenarios of learning how to calculate concentrations by different methods. So here we have a 5%. Now, I could take away one step, and if I just right away change this 5% into what I know is a decimal form of it, then I don't have to worry about this 100% here. So I'm going to go ahead and do that. So instead of me writing 5% and then dividing it by 100%, I'm going to go, oh, well, I already know that that is just in a decimal form, 0.05. So that number is equal to, what I'm looking for is this grams of my solute. So we have to be cognizant enough at this point to know that that's the solute, and then the solution would be just a lithium chloride solution. So that equals some amount, so some grams of lithium chloride over, and it says that it's a 100 gram solution. So 100 grams of the solution. So if I were just to break this down into mathematical numbers, this equals 0.05 x over 100. So pretty simple calculation at this point. Multiply both sides by 100, I end up having 5 grams. 5 grams of what? 5 grams of lithium chloride. The second type of mathematical way we can express concentration is something that's called volume percent. And when would we use this? We would typically use this when we are working with gases or liquids that would be dissolved in a liquid. This should really probably say a liquid solution. So if I'm taking a gas or a liquid and I'm dissolving it into a liquid solution, I might talk about using something like a volume percent. So our formula for this, percent volume is equal to the volume of the solute divided by the volume of the solution. And again, pay attention. What is solution? Well, that would be a solute plus my solvent, and then multiply that by 100%. So a problem we can work through. What is the composition of a solution containing 12 milliliters of ethanol and 100 milliliters of solution? And it tells us to note the volumes of water solutions are usually additive, meaning that we just know that it's a 100 ml solution there. The volumes of other liquids are frequently not additive. Now, this honestly might almost be misplaced at this point. I think it's going to add more stress for you than anything. As we work through some of the practice problems, I think that's going to shed better light at that point. But let's just try this problem. Again, it's truly simple math. If we have, and I'm using the formula that's right here above, so 12 milliliters of my solute, which is my ethanol in this case, over, and it tells me that my entire solution's volume is 100 mils, and then I just simply want to change this to a percent. So very simple math. 12 divided by 100 times 100% becomes 12% solution. So that would be an example of a volume percent. Okay, so the third type is a mass volume percent, and this is probably used most frequently whenever you are working with solids that are dissolved in liquid solutions. Okay, so this is pretty common. The formula for this would be percent MV, just saying that it's a mass volume. So that's all one thing, one number, is equal to the mass of my solute divided by the volume of my solution. I'm going to abbreviate that to give myself room, multiplied by 100%. So we can go through a class example of this one as well. It says that you want to prepare normal saline solution in which to dissolve IV drugs. Its concentration should be 0.92 mass volume sodium chloride. How many grams of sodium chloride should you dissolve to prepare 75 milliliters of normal saline? So my saline solution is 75 mils. We're trying to figure out our mass of our solute in this case. So I'm looking for this mass of solute. They gave me the concentration. Now, because, again, I could do this 0.92 and divide it by 100%, but I can really just do that in my head to eliminate one extra step, and we know that that becomes 0.0092, and that makes me not have to deal with this silly little 100 over here. Okay, I just did that in my head. So that's going to be equal to the mass, and in this case, it'll be in grams, of my sodium chloride divided by 75 mils of my solution. So I'm going to do 75, see if we can get you to see this here, times 0.0092. I end up with 0.69 grams of sodium chloride. Okay. Okay, and then the last one that we're going to learn how to work with today is a concentration that is going to be defined in parts per million. This is probably my favorite. This is the one that whenever we were going to be doing our Flint water study, anytime you're looking at water contamination and different contaminants in our drinking water or other supplies, they talk parts per million. They'll many times talk parts per billion even. So it's a very common way to talk about concentration with contaminants. You don't see it talking like that when you're making your Windex solutions or hydrogen peroxide solutions that we might use, or our rubbing alcohol or anything like that. But when we start talking about contaminants in our own body or in our water supplies or even in foods, they start talking parts per million, because something so small in concentration can still have a pretty devastating effect on the human body. So when would we commonly use it? Okay, it's commonly used to describe air and water contaminants. It could also be used to describe drugs in the human body and even pesticide residues. So the formula for this, and you can imagine once you see how parts per million is done, we don't mess with parts per billion, but it's the same concept of how you would do this for parts per billion. But it would be grams of our solute divided by grams of our solution, and then times 1 million. So let's do this problem, and this is going to be a really good one because it's going to make you have to think just a little bit more with what you're going to be dividing things by. So it tells us the solubility of silver chloride is 0.008 grams per 100 grams of water. What is this concentration in parts per million? So my part per million is going to be my gram of my solute, which that's the silver chloride here, so that's a pretty easy number to play with. But if you turn your brain off, you're going to get it wrong on this next part. Because look at the formula, it's grams of solution. So I can't just put this over 100 because water is my solvent. My solution is the 100 plus the 0.008. So I should really be writing 100.008 here. Okay, we're not going to worry about significant figures, at least at this part, okay, because we do want to combine that together. Okay, then we would multiply that by 1 million. And when we do that, we get 79.99. Now here's where we probably could go, all right, what could we do with significant figures? And I probably would go back to the typed word, and I would say, okay, we should have 1 sig fig, so this becomes 80 parts per million. Okay, so just let you see where it is. This is your reference sheet. If you go all the way to the very last page, just flip it over. This was the page we had all of the last unit, those equations were on. And if you go down in here, these will be the equations that we are looking at. The ones that I just went through were in this box. We haven't introduced you to all of them yet. Mrs. Marcus is going to be teaching you how to use molarity tomorrow. And then this year, molality is actually not going to be required for you guys. So all of those equations are right here. You do not have to memorize them. Well, this is open note anyway, but they're available for you. So your homework, and it's typed in Google Classroom, but just to verbally tell you. Now remember, yesterday you were supposed to do this page as your homework. Let me widen this out a little bit. Mrs. Marcus might have said this, but just in case, you do not have to do page 2. So that one we are having you guys mark out. You do not have to do page 3 in this packet that looks like this. Page 3 you may mark out. You were also told, Merry Christmas, you get to mark out page 4. But now we actually have to do some work. Okay, so then page 5, for homework tonight, we want you to attempt all of page 5. We want you to attempt all of page 6, so that includes the volume percent and the mass volume percent that I just went through. And then page 7, only the part per million, so 16 through 20. Mrs. Marcus is going to be going over molarity tomorrow, okay? So that would be your homework. I'm going to have the answers posted in Google Classroom for you to check. Good luck. If you have questions, then join on one of our conferencings.